Good morning, good afternoon. Today we are going to be working on 2.1 equations with rational coefficients. Rational coefficients just means fractions and decimals is what we're going to be working on. So our I can statement is I can solve with rational coefficients, and then I can write equations needed to solve word problems. Well, first we have to do a little vocab. Multiplicative inverses. It's just two numbers that when multiplied together, or the product, is going to be 1. They're also known as reciprocals. So it's just a fraction flipped, like 3/4 and 4/3. You want to switch the numerator and the denominator. We also have to remember multiplying fractions. Jesse. We multiply the numerator times the numerator and the denominator times the denominator. And then we need to know what coefficient is. And the coefficient is just the numerical or the number that is attached to my variable. So if I have 3x, the 3 is my coefficient. The x is my variable. Variable is always going to be a letter. The coefficient, if there is no coefficient, it's an invisible what? 1. So 1x, if I just have a letter, my coefficient is 1. Very important to remember. So just really quickly, let's talk about reciprocals or multiplicative inverses. So 3/4 was on there, would be 4/3, flipping it around. What about 2/3? What's the multiplicative inverse of that? 3/2. What about 1/5? 5/1, which is just 5. So then, what about 4? What's the multiplicative inverse of 4? Well, put it as a fraction. You're always going to put it as 1, and then flip it would be 1/4. Again, when you are multiplying fractions, I'm going to multiply numerator times numerator, which is, so 4 times 1 is 4. 1 times 4 is 4. 4 divided by 4 is 1. When multiplied together, these two numbers should always equal 1. Okay. Now, equations with rational coefficients. All that again means is we're going to be working now with fractions and decimals. And what you want to do is you want to multiply both sides by the multiplicative inverse or by the reciprocal. So you're going to multiply both sides by the reciprocal. So our first example is 3/4 C equals 18. Now, yes, you could see that my variable is being multiplied by 3/4 right here. And we could then divide both sides by 3/4, right? Divide by 3/4. But then, I'm just going to show you how we're adding a few extra steps that we don't really need. But we're going to do one this way. So 18 divided by 3/4. When dividing fractions, don't ask why. Flip the second and multiply. When dividing fractions, don't ask why. Flip the second and multiply. Well, let's look here. Didn't I say when I have a fraction as a coefficient, I can multiply by its reciprocal, right? So you can either multiply by the reciprocal or divide by 3/4. But when you're dividing by a fraction, you're not asking why. You're flipping the second and multiplying, right? You're doing the same thing, whichever is easiest for you. There's two ways. So I'm going to not do all those steps, and I'm just going to multiply my 3/4 C by 4/3. Because again, my goal is to get 1 C, right? And 4 times 3 is 12. 3 times 4 is 12. 12 divided by 12 is 1. So this changes to 1. 1 C. Do I need that 1? No. But when I do it, whatever I do to one side, I have to do to the other. So I'm going to make 18 a fraction and multiply it by 4/3. How do I make 18 a fraction? Put it over 1. Now, you can just multiply across my top, 18 times 4 and 1 times 3. But it might be easier to simplify before you multiply, right? So I see 18 on top here and 3 on bottom. Those can both be divided by what number? 3, right? 3 divided by 3 is 1. 18 divided by 3 is 6. These numbers are a little easier to do now. 6 times 4 on top, 1 times 1 on the bottom. 24 over 1 is Stop. Oh my gosh. Throw it away. Really ridiculous. Okay. My first problem is 1/5 x equals 12. Reciprocal of 1/5. 5 over 1. So I'm going to multiply both by 5 over 1. 5 over 1 is just what? 5, right? So on this side, I don't really need that 5 over 1 because it's not a fraction. So this 5 over 1 times 1/5, it's reciprocals, right? So they equal 1. So this is just x, or 1x. And then 12 times 5 is 60. That is my answer. I did have a question. Which fraction do you flip and multiply? It's always the one that's the coefficient. It's the one that's attached to the letter. So 5/3, you flip it and multiply it. So 3/5 multiply by 3/5. Okay, this is where, again, you can multiply, or you can simplify before you multiply. So 5 on bottom and 15 on top can both be divided by what? 5. So 5 divided by 5 is 1. 15 divided by 5 is 3. So now it becomes 3 times 3 on top, which is 9. And 1 times 1 on the bottom is 1. So it's just 9 over 1, which is 9. What's left on the right side? Just n, or 1n. Okay, our next two is dealing with negative numbers. You have to remember that a negative times a negative is a positive. A negative times a positive is a negative. If the signs are the same, it's positive. If the signs are different, it's negative. So here I need to multiply by its reciprocal, but that negative has to come with it too, because I want to get a positive 1. So positive 1, because a negative times a negative is a positive 1d. Again, you don't have to write that 1. But then I have to do it to the same thing to this other side, negative 9 over 2. The 4 on top and the 2 on bottom can both be divided by 2. 4 divided by 2 is 2. 2 divided by 2 is 1. So I now have a 2 times negative 9, which is a negative 18, over 1 times 1, which is 1. Which is just, and this looks weird, so I'm going to just write the d. And again, you can change that at any time to any variable you want. Negative 18. Any questions so far? Multiply this by negative 7 over 6. Becomes positive. Negative 24 over 1 times negative 7 over 6. This is where I would simplify beforehand because the 24 times 7 I can't do mentally. But 24 and 6 can both be divided by 6. So 6 divided by 6 is 1. 24 divided by 6 is 4. Negative 4 times a negative 7 is a positive 28. And that equals P. Remember that whatever you do to one side, you have to do to the other. All right, our next one is going to be with mixed numbers. If you ever have mixed numbers, you want to always change them to an improper fraction. So let's review how to change it to improper fraction. So your whole number is your big number. Then you have your numerator and denominator. So you're going to multiply your denominator times the whole number and add the numerator. Again, so 2 times 1 is 2. Add the 1 is 3. So this is 3 over 2. 16 and 1/2. So 2 times 16 is 32. Add the 1 is 33. 33 over 2. So when equations involve mixed numbers, convert to improper fractions first. So this problem, I want you to first change them to improper fractions. So 8 times 1 is 8. Add the 7 is 15 over 8y. Equals 2 times 4 is 8. Add the 1 is 9 over 2. Okay, now I have two fractions, and this is where kids might think, oh, what do I multiply both sides by? Well, what do I multiply both sides by? Yep, but you want to flip it, so you do 8 over, yep. It's whatever's connected to my variable. So 8 over 15, both sides. Okay, these cancel, right? And all I have is y left. Now these I can simplify. 2 and 8 can both be divided by 2. So 4 and 1. And 9 and 15 can both be divided by 3. 3 and 5. So now I have 3 times 4 on top, which is 12. 1 times 5 on the bottom, which is 5. So 12/5. I want to change it back to an improper fraction. So 5 goes into 12 2 times with a remainder of 2. And the denominator always stays the same. Okay. I'm going to do the next one kind of quickly because I'm running out of time. Okay, 24. This is 25 over 6 equals 10 over 3c. Multiply both sides by 3/10. 25 and 10 can both be divided by 5, so 2 and 5, 1 and 2. So then I have 5, 1 times 5 on top, 2 times 2 on the bottom. These cancel out, so I just have c. So I have 5/4 equals c. 4 goes into 5 one time with a remainder of 1, and 4 stays the same. Okay, the last, and I'll come back to this, but I need to talk about it real quick. When you are working with decimals, you want to use the division property of equality. So you're just dividing, take a calculator, you need to divide both sides by that 0.45, 0.45. So 3.15 divided by 0.45. I could get rid of them and move my decimal place 2 places to the right. It's not necessary though, because you can always use the calculator. So and then when I have when I have percents, I need to know that that percent as a decimal, I need to move my decimal, so it's 0.75. Okay, so looking at that. Your assignment, is that?